So how the capacitance of capacitor is changed? It can be changed by inserting different medium between the plates, or by changing the area of the plates, or by changing the distance between the plates. Okay, so capacitance depends on these three things, and these are the formulas when capacitance, equivalence capacitance when they are connected in series and in parallel, and resistance for series and parallel, right? So now we'll be doing some more exercise questions today. So let us take the questions of, as we are doing capacitance, so let us take the questions of capacitance first. So the questions of capacitance, they start from exercise questions, question number 2.23. So here, an electrical technician requires a capacitance of 2 microfarad. So this is the equivalence capacitance, means capacitance of the circuit he requires in a circuit across a potential difference of 1 kilowatt. So the potential difference 1 kilowatt means 1 kilovolt, sorry, 1 kilovolt means 1000 volts. So this is volts, and this physical quantity is potential difference, or we also call it voltage. So now what is the so we need to tell we need 2 microfarad capacitance. Now what we are going to do, we have a number of 1 microfarad capacitors. Okay, so that's what we have. We have to use them so that the equivalent capacitance is 2 microfarad. And each of this, the available capacitors that we have is of 1 microfarad, and they cannot withstand the potential difference of more than, so we maximum that they can withstand is 400 volt. So give them the voltage less than 400 volt. So you need to tell what is the possible arrangement with the minimum capacitors. With the minimum capacitors, what is the arrangement? Okay, this is what you need to tell. So obviously there will be some capacitors which will be in series, some will be in parallel. Okay. Now let there be n capacitors. This minimum capacitors, let it be n. Okay. Let n be the number of capacitors. So now this, if we combine them, like they will be combined if some of them are combined in series. So this minimum capacitor combined in series is n. Not all the capacitors, but the ones which are combined in series is n resistors. Okay. C1, C2 and so on up to Cn. So you know, and there will be the same capacitors will be connected. So there can be these series. See, they are all same. Okay, so capacitance is same. So don't write as C1, C2. You can write them with C also. So because all of them has the same capacitance, that is 1 microfarad C, but this is number 1, number 2 and up to n. Number 1, number 2 and up to n. But how many of them are connected? This combination of n in series. So n capacitance in each series, n capacitors in each series. So how many series of this kind are there? So this is the first series, this is the second series, and let it be like m series total. Okay, so again here, so there are m series. So m capacitors or you can say m series of n capacitors. M series with each series carrying n capacitor. Okay, so this is so how many total capacitors will be there? So the total will be, in each series there is n and there are m series, so total capacitors will be n into m, right? So this will be this kind of arrangement will be there. So now we need to find out what is n and what is m. Now, as I have just discussed with you that in series this potential is divided, but in parallel potential difference is same. So how much is the potential difference? I am providing it to them. I am providing them a potential difference of 1000 volts. So 1000 volt will be there across all the n capacitors. So here also 1000 volt, here also 1000 volt, here also 1000 volt. So this 1000 volt, I need maximum 400 volt. Okay, so I need to divide this 1000 among n capacitors. Okay, and this should be less than the voltage that each capacitor should be getting is less than 400 volt, right? So how much n will be equals to? So n will be equals to, so taking n this side and bring 400 this side, so n will be greater than equal to 1000 upon 400 volt. So n will be greater than, and this comes out to be 2.5. So n must be greater than 2.5, so that, so if n is equals to 3, then how much is the potential they will be getting? So if n is equal to 3, 1000 is there, 333.3 volt, 333.3 volt, 333.3 volt. Understood the question? And so that is less than 400 volt that each one is getting. So this 1000 will be divided among the 3 if n is equals to 3. So it should be greater than 2.5. It is 2. If there are only 2 capacitors, then they will get 500, which is more than 400 volt. Okay? So that's not possible. So capacitors will not work. Okay? So there can be 4 also, but then it will be 250, 250, 250 and 250. But we want minimum capacitors. So this thing that voltage across a capacitor should not be 400 volt. Limit these capacitors number in a series 3. So this is our answer, that in a series there must be 3 capacitors only. Now how many total series will be there? So what is the equivalent capacitance of one series? So these 3 capacitors are there. Now 1 microfarad, 1 microfarad, 1 microfarad. So what is the net capacitance? The net capacitance. So their equivalent capacitance will be, so in series 1 by C is equals to 1 by C1. You can write them as 1 by C2 plus 1 by C3. And if they are all same, you can also write this as C equivalent is equals to 1 upon C plus 1 upon C plus 1 upon C. That is equals to 3 multiply 1 upon C. And C equivalent will be equals to C upon 3. So this will be equals to C upon 3. What is C? 1 microfarad. So 10 to the power minus 6 farad upon 3. Right? So that's your equivalence capacitance. Now you want how much is the total capacitance you want. So in parallel it will be added. So this is or you can simply write it as 1 by 3 microfarad also. So 1 by 3 microfarad and one more series with 1 by 3 microfarad and one more series with 1 by 3 microfarad. So how many these series will be there? Okay, so this we need to tell. So we know in parallel they are going to be added. So C equivalence is equals to N into, so they will be added, right? C is equals to C1 plus C2 plus C3 and they are all same. And so we can write it as C equivalent that we require, and that is what we require is 2 microfarads. So we want 2 microfarad and that is equals to N into 1 by 3 microfarad. So microfarad, it is the same unit. 3 multiplied 2 is 6. So this is M, right? M number of series. So this is M total. So M multiply 1 by 3. Okay. So M comes out to be 6. This microfarad. So M is the number. So this is 6. So 3 capacitors in series and we have 6 series we need. So total capacitors will be M into N and that's equals to 6 multiply 3, 18 capacitors are required for this combination. Okay students, any doubts in this question? If there is any doubt, please ask.
No, sir.
Okay. So let us do, as we are doing capacitors, the questions based on capacitance, let us do the next question also. What is the area of the plates of 2 farad parallel plate capacitor given that the separation between the plates is 0.5 centimeter? So we know when area and distance between the plates is given to us, we have the formula. So if this is vacuum, then permittivity of free space, and then this is the area and this is D. We have the formula C is equals to epsilon naught A by D. So we have, what do we have? Air, vacuum. If nothing is given, it means it is vacuum or air. That's the same thing. So this comes out to be, what we need to find here? What is the separation between the plates? So D equals to epsilon naught A by C. So epsilon naught, so D will come this side. So it's, we need to find the area of the plates here, not D. So the area of the plates here means D will go that side, C into D upon epsilon. So C is 2 Farad, that is SI unit, and A is 0.5 centimeters. So let us change it into meters. So 0.5 centi means 10 to the power minus 2 divided by 8.85. So the value of epsilon will be given to you in exams. Otherwise, you can just remember it, 8.85 to 10 to the power minus 12, and 1 upon 4 pi epsilon naught is equals to 9 into 10 to the power 9. So students, just remember these two values. This one, that is equals to Coulomb's constant K and epsilon naught permittivity of free space. And if you solve it, this will comes out to be 1130 into 10 to the power 6 meter square. So meter square, if you will write it in terms of kilometers, so that is 1130 kilometers square. Okay, so for 2 Farad, and distance between the plate is not much, students, is only 0.5 centimeter. You know how much is 0.5 centimeter? And the capacitance of this capacitor is 2 Farad. So this much is the area. Can you imagine? This much is area. Is it practically possible? No. So this much is the area required for this. If you can further reduce the distance between the plates, but you will have some other problems. So that's the area. Now let us do one more question based on the capacitance. So this was question number 2.24. Next question, 2.25. Students, you will definitely have a question related with capacitance in your exam. Okay, so I think one question will be from the potential or potential energy, and another question will be of capacitance. So you can expect these two questions in your board exam, subjective, and there will be some objective questions also, like equipotential surfaces and some other good questions. Okay, so now we have a figure given to us, and so we have this capacitance C1, which is 100 picofarad, and then this very important question, student, 200 picofarad and 200 picofarad, and then we have 100 picofarad, and this is, so this is capacitor C2, this capacitor C3, this capacitor C4, and voltage applied to it is 300 volt. Okay, so you have to tell the charge and voltage across each capacitor. So charges will be, let it be Q1, Q2, Q3 and Q4, and voltage across them will be V1, V2, V3 and V4. This is what you need to find. So we have same kind of questions for resistors also. So if we understand this, it will be easy for us to do for resistors also. So students, if this formula, if capacitors are connected in series, then 1 by C is equals to 1 by C1 plus 1 by C2. Can we write it like this? C1, C2, C1 plus C2. And can we write it that C is equals to C1, C2 upon C1 plus C2? So this formula we will be directly using for when C1 and C2 are connected in series, okay? And what about parallel? So this is for series, right? For parallel, C is equals to C1 plus C2. So it's better, students, if you use these formulas, right? Okay. Now, what is the meaning of series? So series means and parallel. So in parallel, I have already told you that both the terminals of the capacitors are directly, like this terminal is directly connected with this terminal is directly connected with this terminal. So in parallel, both the terminals are connected, whereas in series, only one of their terminal is connected and other one, there will be some other element in between. So directly connected only one. In series, only one terminal, and in parallel, both the terminals of the capacitors are connected. Now, we'll have clearly we can see that C2 and C3, only one of their arms is connected, right? Or one of their terminals is connected. So we can write this as equivalent circuit. So what will be the equivalence capacitance? They are connected in series. So in series, so the equivalence capacitance of them, or for C1 and C2, let it be assuming as C dash, will be C1 C2 upon C1 plus C2. So these two are in series, and if they are equal, so 200 picofarad into 200 picofarad and divided by 200 plus 200, right? So this is the formula you have used here, and this will comes out to be 4, so 400, so 4 will cancel out and 2 zeros, so I left with 100 picofarad. So this is C dash now, this is C1 and this is C4, right? So this is the equivalent circuit of this one. Now further we can clearly see, students, don't get confused that these three are in parallel. See, these two are in parallel because the terminal of C1 and C dash is connected and C1 and C is connected. But see, that one terminal of C4 is connected with C1, the other one is not connected, okay? So C1 and C2, they are in, so this is 100 picofarad and this is also 100 picofarad, okay? So the equivalence resistance of both of them, of C1 and C dash, let it be C double dash. So this is C double dash and this is C4, and so this I have written with C double dash, right? And this is your 300 volt. So this C double dash, they are connected in parallel. So in parallel the formula is C1 plus C2, very simple. So 100 plus 100, that is equals to 200 picofarad, right? Now these two are connected in series. See, only one of their terminal is connected, another one is not connected directly, so they are connected in series. Don't get confused. This figure is same as, see, take this anywhere on the circuit, this C4. Let me take C4 over here. So this is C4, right? And this is C double dash, and this 300 volt. You can move anywhere. So it can be here or it can be here. So student, this is the same circuit, and clearly they are in a series. Only one of their arm is connected. Okay. Now for this is how much? C double dash 200 picofarad. And how much is this one? C4 100 picofarad. So what is the net equivalence resistance of the circuit? So that is, you can say it's C triple dash, or let it call only C. It will work. Yes, we have not taken the symbol C yet. They are C1, C2, C3, C4, and this equivalence resistance is C dash, and this equivalence resistance is C double dash. So C will be in parallel. What is the formula for parallel? They are in series. So what is the formula for series? This one. So 200 and 100. So 200 multiply 100 divided by 200 plus 100. So students, what this comes out to be? This comes out to be 200 upon 3 picofarad. Okay. So now this is your capacitance, equivalence capacitance of the whole circuit. Now this is the capacitance, and for this capacitance you are applying the voltage of 300 volt. So what will be the charge on each of the plates? The charge will be, so now what does this mean? This mean, let me tell you, this means now you have one capacitor. This is your C, which is representing the whole circuit, okay? And this is your 300 volt. Okay, this is what does it mean. Now if this positive terminal, this is negative, so there will be positive Q charge on this plate and there will be negative Q charge on this plate. Okay, now you need to tell how much is the charge Q on each plate. So C is equals to Q by V. So Q will be equals to C into V. So what is C? 200 upon 3 picofarad. What is pico? 10 raised to the power minus 12. Right? So 200 into 10 to the power minus 200 upon 3 to 10 to the power minus 12 into, what is voltage? 300 volt. And this comes out to be 2 into 10 to the power minus 8 coulombs. So student, this is the charge. Okay? Now I have discussed with you in the beginning that let me remind you again that in series the voltage is divided and charge is same. In the parallel, voltage is same, charge is divided. So if I have charge Q, so I will have here Q1 and I will have here Q2, where Q is equals to Q1 plus Q2. Okay, for parallel. And for series, I have connected this with voltage V, so V is equals to V1 plus V2. Charge is same. So students, this is the thing that we are going to apply here. Okay. Now this was they were in series, C4 and C dash, right? And I have written this. So what is same in series? It is the charge. So it means on both of them the charge is same. So on this also the charge is, if I am writing this charge as Q, so Q4 will also be 2 into, so I have Q4 charge over here, so that is same as Q, and on this also the charge will be, so Q is, this is the same, right? So Q4 will be equals to 2 into 10 to the power minus 8 coulombs. And what about the voltage? So voltage is same, means voltage will be divided, right? So how much will be the voltage? You know Q4. So after knowing Q4, you can write the voltage. So V4 is equals to Q4 upon C4, and that's equals to 2 into 10 to the power minus 8 upon C4, that is 100 picofarad. So that is, now in SI units you have to write, students, and that comes out to be 200 volt. So now we have found Q4 and V4, right? Now we have reached this C double dash. We know, what do we know about this C double dash? We know about, let us draw this again. So this we have drawn. So this circuit we have got from this, so either this or this is the same, so we have got this from this, right? So let us draw them. So we know this C double dash, so the charge is Q here, and what will be the voltage? So if I have 200 volt over here, so in series voltage is divided, so if it is 300, what will be the voltage here? 100 volt. Okay, so 100 volt is there with C double dash, 200 volt is gone with C4. Okay, 100 is remaining. So now 100 is remaining. So let me make this diagram. So C double dash, it has the capacitor C double dash, we got it from C1 and C dash. So now C1 is 100 picofarad and C dash, this is C1, and C dash is again 100 picofarad. So this C1, this C4, C double dash, you have got it, C double dash, you have got from this C1 and C dash. So the voltage available for them is now 100 volt only, right? 100 volt. And what is the charge available to them? Charge available to them is same as it was for C4. So same charge, 2 into 10 to the power minus 8 coulombs. So that is the availability with this combination. So what is same in the parallel? So students, start with the same thing. Here it was series, we started with the same thing, that was charge. So charge was same, and then we find the voltage. So here voltage is same, so start with the voltage here. Okay, so what is the volt? 100 volt. So here also 100 volt, and here also 100 volt, right? And what about the charge now? So this is C1. So let us find the charge here. So charge will be divided, so some charge here and rest of the charge will be with this C dash. Okay, so C is equals to Q by V, and we have to find here Q1, so C1 is equals to Q1 into V1, so Q1 is equals to C1 V1. What is C1? 100 picofarad. What is V1? 100 volt. So this comes out to be 8 into 10 raised to power. What is the standard international unit of charge? Coulombs. So that is a charge over here. 8 into 1 into 10 raised to power 8, right? So total was 2 into 10 raised to power 8. So how much is the charge with C dash? Obviously half will be divided. So charge available with it will be 10 raised to power minus 8. Because the charge with Q1 plus Q dash, let the charge here with the Q dash, that was total 2 into 10 raised to power minus 8 coulomb. So this means that Q dash is equals to, so this is 10 raised to power 8, 1 into 10 raised to power 8, so you are left with one part, so half of it. Okay, so here obviously because the capacitance is same, so half charge will be gone to both of them. Now we have found the V1 V4 Q4, and that was V1 100 volt, and this is Q1. So this was your Q1 and this was your V1, right? This is your Q4 and this is your V4. Okay, so now for capacitor 2 and 3. So students, capacitor 2 and 3, we got this circuit from here. So these two are C2 and C3. They were in series, and we have written their equivalence capacitance C dash. They were in parallel. Okay, so they are in C dash in series. So now what is the voltage and charge available with C dash? So they are in series, right? And what is the voltage available to them? And what is the charge available to them? C dash. So the charge available with them is 10 to the power minus 8 coulomb is the charge available with them, that is Q dash. And what is the voltage available with them? Voltage available with them is C dash, means this Q dash is the voltage available with them, which is 100 volt. So 100 volt is available with them, and this is C1 and C2. So sorry, C2 and C3. C2 and C3. See here, they are C2 and C3, and their net capacitance we have written as here, right? So C2 and C3. So that was this C dash written as C2, C3. So the voltage available to them is 100 volt, and the charge available for them is 10 to the power 8 minus coulombs. So what is same in series? Charge is same in series. So the charge is same as this 10 to the power minus 8. So the charge over here is for C2, Q2 is equals to 10 to the power minus 8 coulombs, and Q3 is also 10 to the power minus 8 coulombs, because charge is same in series. Now, if I know C2 and Q2, so C2 is equals to Q2 by V2. I can find the voltage which will be divided, 100 voltage will be divided among these two. So that will be equals to V2 is equals to Q2 by C2. C is equals to Q by V, and see, both are same, 200 microfarad, 200 microfarad, and charge will be same. So this voltage will actually be equally divided, 50 volt, 50 volt. You can directly write also, because capacitance is same, so voltage will be divided equally. You can find it from here also. You will find the answer as 50 volt. So Q2 is 10 to the power -8 coulombs divided by 200 picofarad. So 200 to 10 to the power -12, right? And this comes out to be so this is 10 to the power -4. So 1 upon 200 into 10 to the power -4 will be 10 to the power 4. So 4 zeros. So 2 zeros will be cancelled out, and 2, it is 50. So students, I was telling you that the capacitance is same, so this 100 volt will be divided equally, 50 volt and 50 volt. So now you have calculated 1 of the volt, so the total will be 100. So therefore V3 is equals to 100 minus 50. The total available to them was 100, that was V dash. So V dash minus V2, and this comes out to be 50 volt. So Q2 this, V2 this, Q3 this, and V3 this. So students, this question was, next time when you will do it, this question is not going to take so much of time. Okay, very simple question, making the equivalent circuits, okay, and reaching to the single circuit, and then you need to go back. Okay, considering the thing that if something is there in the series, then the charges are same, and start from the charges, and and you know the capacitance, so you can find V1 and V2. And if the capacitance are in parallel, then voltages will be same. So you know the voltage, you know the capacitance, you can find the charge. So charge will be divided in parallel. So students, this way you can solve this question easily. Very important question. Concept wise also this is very important. Let us do, and this question was there in CBSE also. Now let us do one more question. 2.26. Students, watch this video once more, okay, and do the numericals simultaneously along with me. Right now you can also do, okay, there's no problem at all, no issue at all, and you need not to write this much. You can write everything in short, okay. So I have written all this, I have drawn all these circuits just to explain you the concept, because the same concept will be there in the resistance. Same concept is there for the resistance, students, exactly same. The formula for series and parallel will be interchanged. So I have not explained you only this capacitance thing, but also the resistance. So you might find one of them in your exams. And concept wise that is very much required. Now let us do the next question. The plates of a parallel plate capacitor have an area of 90 centimeter square. So area is equals to 90 centimeter square, and they are separated by distance of, so D is equals to 2.5 millimeter. The capacitor is charged by connecting it to 400 volt supply. So the voltage that I am providing is 400 volt. Okay. How much is the energy stored by the capacitor? So this is the first part. How much is the energy stored by the capacitor? So what is the formula for energy stored? Half CV square, and also equals to, so we have three formulas. C is equals to Q by V. So put the value of C here, Q by V. So this you will get Q by V. So one V will be cancelled out. So QV, right? C is equals to Q by V into V square, so 1 V will be cancelled out. So you will be left with C is equals to QV. Now you can put the value of V now. V is equals to Q by C. So Q square by C square. So 1 C will be cancelled out. I left with Q square by C. So these are the two formulas. These two used very commonly. Now you have the voltage with you. So you need the capacitance of this capacitor, which has this geometry. So very easy to find the capacitance. Okay, voltage is given to you, so you can easily find it. So what is the capacitance? Capacitance is equals to epsilon naught A by D. So epsilon naught A by D, epsilon naught, you know the value, 8.85, we have used it earlier also today, minus 10 to the power 12. And what is the area? That is 90 centimeters square. So centimeter is centimeters 10 raised to the minus 2 meters and then whole square of it. Okay, so that's what it is. Divided by the distance, that is equals to 25 millimeters. So 2.5 milli means 10 raised to the minus 3 meters. And this comes out to be, so the unit will be Farad, of course, and this will be 31.86 picofarad, 10 to the minus 12. Okay, so this is the capacitance. So put this capacitance here. So 1 by 2 into 31.86, and so you can also put this value C also here. You need not to calculate this even. It will be easy for you to do the calculations, right? So 8.85 into 10 to the minus 12 into 9 into 10 to the minus 3 divided by 2.5 into 10 to the minus 3 multiplied by V, that is 400 volt into 400 volt. So this is the formula that I have used for potential energy stored in the capacitor, and this comes out to be, when you solve it, 2.55 into 10 to the minus 6 joules. So that is the electrostatic energy stored, that can be stored by this capacitor. Now the next part is, view this energy stored in the electrostatic field. So where is this energy stored? In the electric field. This energy is stored in the electric field between the plates. Okay, and now obtain the energy per unit volume, that is energy density. So what is energy density? So energy density written by small letters, so that is small u is equals to total energy divided by the volume. Okay, so what is total energy? This is total energy. What is volume? Volume is A into D. So you know the value of A, you know the value of D. So putting them, so A is 9 into 10 raised to the power minus 3 into D is 2.5 into 10 raised to the power minus 3. So this the unit will be, of course, units of energy is joules, and this is meter cube. So the units will be, you will get 1.13 into 10 raised to the power, or you can also write this as 0.113 joules per meter cube. Okay, so Can we make this a little bit shorter? Is there any other way? Yes, you can solve it algebraically. What is the value of u? U is equals to half into C. What is C? C is epsilon naught A by D, right? Into V square. Okay, divided by the volume. What is volume? Volume is A into D. So this A will cancel out. Okay. And what is electric field between the plates? Because he likes to discuss it in this way. So electric field between the plates, we know it already, that here the field is added, right? If this is positive, this is negative, so field due to positive this side, and due to negative it will be towards it, so it will be added. So E is equals to, you remember, 2 epsilon naught plus nu upon 2 epsilon naught, and it will comes out to nu upon epsilon naught is the electric field. So electric field between the plates. And further, the formula that we have in terms of V, electric field is equals to V by D. Remember, E is equals to K Q by R square, so that is R into R, and V is equals to K Q by R. So this K Q by R is V, so that is V upon R, or if R is the distance, you can write it as V upon D. So this is the thing. So students, now this is what you have. So V by D, you have V by D square, so this is 1 upon 2 epsilon naught V by D whole square, right? And this is written as 1 by 2, so this V by D is E, so epsilon naught E square. So that is what your energy density is. This derivation we have already done, so again derived. Now we have one more simple question, that is, let us do it also, 2.27. So students, we have a 4 microfarad capacitor, and this capacitor is charged to 200 volt supply. So the capacitance is 4 microfarad and the voltage is 200 volt. It is then disconnected from the supply and then connected to another uncharged capacitor, that is 2 microfarad. How much the electrostatic energy of the first capacitor is lost in the form of heat and electromagnetic radiation? Students, we have done this kind of questions earlier also. So this is the same question as the last example, and we did this type of question yesterday also. So I feel that there's no need to do it again, but there might be some new students, so for their sake, let me do it once more for you. So I have this 4 microfarad, this is 200 volt. So this plus positive or negative, so plus Q will appear over here, minus Q will appear over here after it is charged. So now, how much is the electrostatic energy stored in it? So as I told you that we have these many formulas of the electrostatic field, right? These many formulas. So U is equals to half CV square, that is equals to half QV. We know we will need both these formulas. So the energy with this system was U is equals to half CV square, because we have the C, we have the V. So that's equals to half into 4 into 10 to the power minus 6, that is 4 microfarad, micro 10 to the power minus 6, and that is voltage is 200 per square, and that comes out to be 8 into 10 to the power minus 2 joules. So this is the energy stored in this capacitor. Now what happens is that it is then disconnected and connected with the capacitor of So this was 4 microfarad and this is 2 microfarad after it was charged. Okay. Now, how much is the energy does it has? So this is suppose we need to find the change in energy, right? Change in energy means U final minus U initial. So this was the initial energy. And the question is, how much is the electrostatic energy lost? Okay, so if you want to write lost, you already know that energy is lost. So you can directly write U lost. It means that energy is lost. This is lesser, right? The final will be lesser and initial is more. So you can directly write Ui minus Uf. So that's the difference. So if you are writing change is always final minus initial. But you are writing here lost. So lost means now greater minus smaller, right? Okay. So we need to find Uf also. Okay. To find this Ui we know. So what is now in parallel we have done. So what will be same? So how much will be the charge? So how much was the charge on 4? Students, it's better if you can just open your NCERT and you can just see the example 2.10. It is similar to example 2.10, and in that question the capacitors were same, but here the capacitors are different. So their common potential difference. Let us first find the charges on this capacitor 4. So charge will be on this capacitor, in this case charge will be CV, and that will be 4 into 10 to the power minus 6 into 200, that's 8 into 10 to the power minus 4 coulomb. Now let us consider now this case. This case is over. So they are connected together, so both will attain the common potential, so the potential will be same. Okay, now what is this total, what is this potential will be? This potential difference same, right? What is it? V is equals to Q by C. So let it be V dash Q dash C dash. So that's equals to Q dash. So charge will remain the same as Q. Okay. And what is the equivalence resistance of this circuit? So they are connected in parallel. So C1 plus C2. So 4 plus 2 6, right? So this is 6 microfarad. So what is the charge? 8 into 10 to the power minus 4 divided by 6 into 10 to the power minus 12. So this comes out to be 400 upon 3 volt. So this will be the voltage that they will have. Now you know the voltage, and now you can write the formula. UF is equals to same half CV square. So half, and C is here this 6 microfarad. So microfarad, this is 10 raised to the power minus 6. Okay, so 6 into 10 raised to the power minus 6 into V square. So 400 upon 3 square, right? And this comes out to be 5.33 into 10 to the power minus 2 joules. So students, this is the final energy. So what is the energy lost? So now energy lost potential energy lost is equals to initial minus final, and this comes out to be, so it was 8 minus 5.33, so 8 into 10 raised to the power minus 4. So this is 8 into 10 to the power minus joules, not the charge but the energy we are writing. 8 into 10 to the power minus 2 joules minus 5.33 into 10 to the power minus 2 joules. So this will comes out to be 2.67 into 10 to the power minus 2 joules. So this is the energy lost. How is this energy lost? This energy is lost because the charge was transferred from this to this and this to this plate. So when charged particles accelerate, they lose energy. They lose energy in the form of electromagnetic waves or electromagnetic radiations. So that's how the energy initial was more and final was lesser, and that was is the change. But student, the example 2.10 and the one more NCERT question which is of same type, that was 2.11. so this is example and exercise question, same exercise that we are doing. Exercise question 2.11 is also same. They have this same capacitor. So see the video, last video, yesterday's video, and see how I have solved this question 2.11. That's important. Okay, so that's all for today. Thank you so much for